Let g of x equals 4 minus 2x. We're asked to find all values of x for which g of x is less than negative 3 or g of x is greater than 3. So to start, since we know that g of x is 4 minus 2x, then I'll go ahead and create two inequalities. The first one is here. It tells me that g of x, which is 4 minus 2x, needs to be less than negative 3, and then I'll go ahead and put the word or here because that's important. And then they tell me the second one is g of x, which is 4 minus 2x, is also greater than 3. So these are the two inequalities that I need to solve. So I'll start with the one on the left. Isolating x, I need to subtract 4 from both sides. So this gives me negative 2x is less than negative 7. And then to isolate x, I need to divide by a negative 2. Now remember, dividing by a negative, to keep it a true statement then, we must switch the inequality's direction. So now x must be greater than positive 7/2. I'll go ahead and bring down my or here, and now I need to solve the other one the same way. So isolating x, I need to subtract 4 from both sides. This gives me negative 2x is greater than negative 1. Once again, I'm dividing by a negative, so divide by negative 2 here. Which, to keep a true statement then, I must change the direction of my inequality. So x must be less than 1/2. So the algebraic way to write this in set builder notation is right here. But if we're also going to use interval notation, then we must start smallest to largest. So this inequality contains the smaller set of numbers. So x is less than 1/2 would be written as negative infinity to 1/2. And since it doesn't include 1/2, I need to use the round parenthesis. And then the word or will become a union symbol to connect these two sets of numbers. And the other set of numbers is all the numbers greater than 7/2. So it will start at 7/2 but won't include 7/2 and go to infinity. So this is the same solution set, but now in interval notation.